Hello, Unit 1, Atomic Structure. Bohr's atomic model, Bohr's theory. Rutherford atomic theory has two serious limitations about stability of atom and hydrogen spectrum. In order to remove these two limitations, Neil Bohr proposed his own atomic model of atom. Bohr's theory particularly depends on the Rutherford's theory and particularly on Planck's quantum theory. Postulates of Bohr's atomic theory: an atom consists positively charged nucleus at the center. Electron revolves around the nucleus in circular path with fixed amount of energy. These circular paths are called stationary energy level or cell or orbits. Since energy is quantized, an electron cannot radiate its energy continuously as it keeps on revolving around the nucleus in its own cell. An electron, while revolving around the nucleus, neither absorb nor radiate its energy. That's why electron keeps on revolving around the nucleus and does not collapse into the nucleus. Ordinary electrons revolve around the nucleus in its own orbit without observing or radiating its energy. This state is called ground state, which is most stable state of an atom. If energy is supplied to an atom which is absorbed by an electron and promoted to higher energy level, this state is called excited state, which is unstable state of electron. When electron jumps back to the lower energy level, emit energy in the form of photons having the specific frequencies, thus given relation E equal to Hv, delta E equal to E2 minus U1 Sb, E2 higher energy level, U1 lower energy level. Centripetal force and centrifugal force are exactly balanced. Electron cannot revolve round the nucleus in all orbits arbitrarily. Electron revolves only these orbits in which its angular momentum is integral multiple of the factor s over 2 pi. This is called quantization of angular momentum. That is, the angular momentum of electron must be quantized. Ambient equal to nh by 2 pi, where r radius of orbit, the mass of electron is Planck's constant and principal quantum number. Advantage of Bohr's theory. Bohr's theory explained the stability of an atom. That is why electron does not collapse into the nucleus. Bohr's theory satisfactorily explains the origin of line spectrum of hydrogen. Bohr's theory can be used quantitatively to determine radius of orbit, energy of electron in particular orbit, frequency, wave number, and wavelength of energy radiated in electronic transitions. Drawbacks of Bohr's theory. Bohr's theory only explained the spectrum of hydrogen and hydrogen-like species, He+, Li++. It does not explain further splitting of spectral fine structure. In presence of magnetic field and electric field stark fake, it does not explain three-dimensional structure of atom. Application Bohr's theory, determination of radius of Young orbit in hydrogen atom. Hydrogen is the simplest atom. It has only one positive charge in nucleus Z equal to 1 and single electron revolve in the orbit. According to laws of classical mechanics, the centripetal force acting on electron equal to Z square over 4 pi R square Coulomb's law, where Z is atomic number is charge on electron, option absolute permittivity or radius of orbit. However, centrifugal force acting on electron mv square over r, where m mass of electron, the velocity of electron, centrifugal force tends to away from its orbit when two forces are balanced. Centrifugal force equal to centrifugal force z square over 4 pi r square equal to m square r. So v square is z square for pi rm. Question first. From Bohr's theory, MBR equal to n is by 2y, squaring on both sides, m square v square r square equal to n square 4 pi squared. So v square equal to n square 4 r square m square pi square. Equation second. From equation first and second, z square 4 pi rm equal to n square 4 r square m square pi squared. So z square 4 pi rm equal to n square 4 pi r square m square. So you can calculate z square n square s square rm phi and r equal to n square s square pi m z square. Equation third, m equal to 9.109 10 to the power minus 31 kg, h equal to 6.625 10 to the power 34 joule per second. Option 8.854 10 to the power minus 12 per gram per meter cube square. Z equal to 1 equal to 1.602 10 to the power minus 9 coulomb. Pi equal to 3.14. Calculation of total energy of electron revolving in the n shell in the hydrogen atom. Total energy associated with an electron in any orbit is the sum of its kinetic and potential energy. We know that, therefore, of attraction between nucleus and electron is given by Coulomb's law. F equal to Q1 Q2 for pi r square Z E charge. So 4 pi r square, z square 4 pi r square. Work done when the electron moves through the distance dr, work done equal F into d, z square 4 pi r square dr. Total work done in bringing electron from infinity to distance r is given by r infinity z square 4 pi r square dr. So z square 4 pi 1 over minus 2 plus 1 r minus square plus 1 z squared 4 pi epsilon 1 by 1, so minus z squared 4 pi r, so that potential energy equal to minus z squared 4 pi r. Option IV. We know that kinetic energy of electron, kinetic energy half m square. Again, we know that centrifugal force equal to centrifugal force. Z square equal to 4 pi r square, m square r, so m square equal to z square 4 pi r. Substituting the value of m square in equation V, kinetic energy is equal to half z square 4 pi r. Equation BI, total energy of electron E equal to kinetic energy plus potential energy. So 1 over 8 z square pi r minus z square 4 pi r, so equal to minus z square 8 pi r. Equation 7. Substituting the value of r from the equation third in equation 7 equal to minus z square 8 pi n square pi m z squared. So solving equal to minus z square pi z square n power 4 at epsilon square s square n squared. As the value of n increases, the energy of the electron increases. Therefore, energy of electron in outer orbits has greater energy. Origin of line spectrum of hydrogen in light of Bohr's theory. Explain the spectrum of hydrogen in light of Bohr's theory. When high voltage electric discharge is passed through the gas discharge tube filled with the hydrogen gas, the molecular hydrogen is split into atomic hydrogen. Hydrogen's atoms absorbs different amount of energy and promoted to higher energy level. These higher energy states are excited states. Excitation of electron to higher energy level depends on the amount of energy absorbed. Example, electron may be excited to up to infinity with a lifetime very short. They jump to back lower energy level and emit energy in the form of photon having the specific frequencies. When this radiation is passed through a prism, gets dispersed on photographic plate and hydrogen spectrum. This spectrum consists of finite series of lines in different regions of spectrum. Electron transition for the hydrogen atom, Lyman series, Balmer series, Falcon series, and Brackett series. Determination of frequency of number and of length, different lines in hydrogen spectrum. Let an electron jump from higher energy level N2 having the energy E2 to lower energy level N1 having the energy E1. The energy related in their transition is given by delta E equal to E2 minus E1. So minus ZE squared e power 4 over M 8. Okay, so delta E equal to solving the delta E equal to delta E equal to e power 4 m 8 epsilon square is squared 1 over n1 square minus 1 over n2 square equation first. This is the energy radiated or released when an electron drops from higher energy level to lower energy level. This equation can be used to determine the energy release when an electron drops from higher energy level to lower energy level by substituting the value of n2 and n1. Determination of frequency according to Planck's equation, energy associated with radiation is given by where as Planck's constant be frequency. From Planck's equation, the energy associated with the radiation equal to Sv, B equal to E over H, where H Planck's constant be frequency of radiation. We know that from equation 1 equal to e power 4 of h power epsilon squared h squared 1 over n squared minus 1 over n squared equation 2. So that V equal to e power 4 m at epsilon square h squared 1 over n1 square minus 1 over n2 squared. So B equal to e power 4 m at epsilon square s cube 1 over n1 square minus 1 over n2 square. Question third can be used to determine the frequency of radiation emitted when an electron jumps from higher energy level to lower energy level by substituting value of n1 and n2. Determination of wave number, radiation v bar equal to frequency over velocity of light v over c. So substituting the value of v from equation third, v bar equal to r 1 over n1 square minus 1 over n2 square r equal to 4m at epsilon squared. See velocity of light 3 into 10 to the power 8 r 1.097 10 to the power 7 per meter. R Rydberg constant. Representation of spectral series of hydrogen spectrum by Rydberg equation for Lyman series n1 equal to 1, n2 equal to 2 to the power up to infinity. So B equal to R 1 over 1 squared minus 1 over n2 squared. Balmer series n1 equal to 2, n2 equal up to infinity. For Facant series n1 equal to 3, n2 equal up to infinity. For bracket series n1 equal to 4, n2 equal up to infinity. For font series n1 equal to 5 n equal to up to infinity. Determination of wavelength. Wavelength can be defined as the distance between the two successive crests or troughs of the wave. It is measured in the direction of the wave. The wavelength is reciprocal of the wave number. We know that v bar equal to e power 4 m over power 4 over m at epsilon square cs cube 1 over n1 square minus 1 over n2 square or 1 over n1 square minus 1 over n2 square. So that lambda equal to 1 upon r 1 over n1 square minus 1 over n2 square. Refinement of Bohr's theory. Sommerfeld elliptical orbit n equal to 4, n equal to 1, 0, and n equal to 2, n equal to 3, n equal to 4, and also so k equal to 1, k equal to 2, and k equal to 3. From this diagram, n equal to 4, k equal to 4, it is circle, and decreasing the value of k and going to increasing the elliptical. It is also called Bohr-Sommerfeld theory. According to this theory, an electron revolving around its central positively charged nucleus is also influenced by the nuclear charge that is set into motion into elliptical orbits with the nucleus situated at one foci. Sommerfeld related the principles quantum numbers and azimuthal quantum numbers H order as n over k equal to length of major axis, length of minor axis. If n equal to k, the orbit is circular, but when k becomes smaller, the orbit becomes elliptical as shown in the above figure. Limitation of Bohr's model and shortcoming of the Bohr's theory fails to explain the spectra of the multi-electron atoms. It also fails to explain the effect of magnetic field, Zeeman effect. Bohr's theory treats the electron only as the particle, but de Broglie suggested that as particle as well as wave, that is the dual. Bohr also tells electron revolve in well-defined orbits around the nucleus, but not reasonable. Heisenberg's uncertainty principle says that it is impossible to determine simultaneously the exact position and momentum of a small having the particle like electron. Heisenberg's uncertainty principle states that impossible to determine the exact position and momentum of subatomic particles simultaneously with great accuracy. Let delta x be the uncertainty in the measurement of position and delta p be the uncertainty in the measurement of momentum. So delta x, delta p less than equal to 1 over s pi. Delta x means position, delta p momentum, where delta x uncertainty involved in position, delta p uncertainty in momentum is Planck's constant. Generally, the above relation is written as delta x, delta p s over 4 pi delta p equal to m delta b, where m mass of the particle, delta b uncertainty in velocity. So delta x m delta b s over 4 pi. De Broglie equation according to Planck's equation equal to SB, Planck's constant, frequency of radiation. According to Einstein mass of equivalence relation equal to mc squared. From the equation 1 and 2, as v equal to mc squared, so s c over lambda mc squared, lambda equal to s over mc. So equation third is called de Broglie equation. Quantum single packet of energy or matter. Quantum means mechanics means branch of physical science that deals with the energy and force that affect the body. Wave or quantum mechanical model, the atomic model that could explain the particle and what nature of electron is called wave mechanical model of atom. And the atom model is described by Erwin Schrödinger. The wave mechanical model of atom include following concepts: Bohr concept, particle, nature of electron. Electron wave is compared to stationary or standing wave formed by a vibrating fixed between 2 points. Energy values of the electron are quantized as calculated by Bohr. De Broglie concept particle nature of the wave. A stream of electron is associated with a wave whose wavelength is given by the de Broglie relationship lambda s over p. Heisenberg uncertainty principle govern atomic particle. The term probability distribution is used to describe motion of the electron. This model defines an atom as positively charged nucleus surrounded by a stationary electron cloud which extends in both circular orbit. Schrödinger wave equation time independent. Schrödinger developed a fundamental wave equation based on de Broglie concept of behavior of electron in motion. The Schrödinger equation describes the wave properties of electron in terms of its position, mass, total energy, and potential energy. The equation is based on the wave functions which describe electrons' wave in space. The equation can be written in the many forms, on one of which is written as dava square psi over dava x squared plus dava square psi over dava y squared plus dava square psi over dava z squared plus 8 pi square m over s square e minus b psi equal to 0. So dava squared, dava x squared plus dava square dava y squared plus dava square psi plus 8 pi square m square e minus b psi equal to 0. The Laplacian operator square psi plus 8 pi square m over s square e minus b psi equal to 0. For xyz space coordinates of the electron wave with respect to the nucleus, Laplacian square operator mass of the electron as Planck's constant, total energy of electron, potential energy of electron, kinetic energy E minus B, kinetic energy of electron. Psi, a mathematical function call of the function, it represents the amplitude of electron wave around the nucleus at various points in the three-dimensional space. Derivation of Schrodinger wave equation consider a stationary wave associated with a microscopic particle like electrons moving in the x direction. The wave equation for the stationary wave is given by psi equal to a sine 2 pi x over lambda equation first, where psi is the wave function x displacement of wave along the x-axis, a amplitude of wave, lambda wavelength. Differentiating equation 1 with respect to x, d psi over dx, a cos 2 pi x over lambda, 2 pi over lambda, d psi over dx equal to 2 pi a lambda cos 2 pi x over lambda, equation 2. Differentiating equation 2 with respect to x, d square psi over dx square, 2 pi a over lambda minus sine 2 pi x over lambda, 2 pi over lambda. D square psi over dx square equal to minus 4 pi square lambda square is sine 2 pi x over lambda, equation 3. From the d product equation, h equal to lambda equal to h by mb, equation 4. M, mass of the microscopic particle, b, velocity of particle, lambda square h square m square b square, equation 5. Substituting the value of lambda square in equation 3, d square psi over d square equal to minus 4 pi square h square m square b square psi. D square psi over dx square equal to minus 4 pi square m square b square square psi equal to equation 6. Total energy equal to kinetic energy, potential energy equal to half m square plus b, potential energy, half m square equal to E minus b, so m square equal to E minus b, equation 7. From equation 6 and 7, we can write d square psi over dx square equal to minus 4 pi square m square E minus b square psi. So d square psi over dx square equal to minus 8 pi square m E minus b square s square over psi. So d square psi over dx square plus d 8 pi square m E minus b square psi equal 0, equation 8. Equation is 8 is the particle in the one dimension. Similarly, particle in the three-dimensional box, we can write d square psi over dx square plus d square psi over dy square plus d square psi over dz square plus 8 pi square m E minus b square psi equal to 0, equation 9. Since equation 9 does not contain time and it is called time-independent Schrodinger equation, the equation 9 is also written as double square psi double x square plus double square psi double y square plus double square psi over double z square plus 8 pi square m E minus b square psi equal to 0, equation 10. So double square psi over double square, you can common the psi and double square psi double square plus double square y square plus double square double z square psi 8 pi square m E minus b square psi equal to 0, equation 11. So Laplacian square operator square psi plus 8 pi square m E minus b square psi equal to 0, equation 12. Laplacian operator equation 12 is the Schrodinger wave equation. Conditions should be obeyed by proper wave function. The wave function psi must be single valued, no two probabilities for an electron at any position. The wave function psi and its derivatives must be continuous. Probability must be defined at all positions in space. The wave function psi must be finite, psi equal to 0 as r equal to infinity. The probability of finding the electron over all space from plus infinity to minus space must be equal to 1. So minus infinity to plus infinity dx dy equal to 1. This is also called normalizing the wave equation. Solution to wave equation that are physically possible must have four special properties. What are they? What are the main conditions which psi is satisfied to give the meaningful solution? What conditions should obey the proper wave function? Probability of wave function. Probability of wave function are fundamental to quantum mechanics, describing the quantum state of particle or system. Radial distribution wave function, angular wave function. Radial distribution wave function, let us take a space having the radius r. It is divided into number of concentric one center. Have one center spherical shell having the thickness dr and the Volume of such concentric spherical cell is given by 4 pi r squared dr. Radial distribution force obtained by 4 pi r squared dr psi square versus r is called radial distribution force, where 4 pi r squared dr psi square the radial distribution function, r is distance from the nucleus. Radial distribution curves for 1s, 2s, 2p, 3s, 3p, and 3d are plotted as below as following. If n is the principal quantum number, L is azimuthal quantum number, L equal to 0 to n minus 1, n equal to 3, L equal to 0 to 3 minus 1, so 0 to 2, 0, 1 to SPD. We know that number of peaks in the curves n minus L for the 3 soft cell, n equal to 3, L equal to 0, so 3 minus 0, 3. For 3p soft cells, n equal to 3, L equal to 1, 3 minus 1, 2. 3d soft cell, 3, n equal to 3, L equal to 2, n minus 2, 1. It's the 3p, it's the 3s, 3d, and 4f, 1s, 2s, 5d, 4p, 2p, so on. Pieces of radial distribution curves, the probability of finding the electron is 0 at the nucleus r equal to 0, and the most probable distance of the finding electron increases markedly as the principal quantum number n increases. The most probable radius for the probability of finding electron decreases slightly as the azimuthal quantum number L increases with n remains constant. Number of peaks present in the radial distribution curve Ns, Np, and Nd orbitals are equal 1s, 2p, 3. The penetration power of the SPD and F orbital decreases in order Ns, Np, Np, and Nf least, so that S orbital has highest penetration power, that is lies nearest the nucleus, then other orbitals. The region around the nucleus at which the probability of finding an electron is 0 is called node. The number of nodes present in the radial distribution curves are equal to n minus 1, n minus 2, n minus 3 respectively. Angular wave function. According to Bohr's theory, in hydrogen atom, electron always revolve around the nucleus at distance of 0.529 Armstrong. But according to the wave mechanical approach, an electron can be found anywhere around the nucleus. However, the maximum probability lies at the distance 0.529 Armstrong. This distance is called radius of maximum probability. Quantum number, quantum numbers are the identification numbers for an individual electron in an atom. Principal quantum number, it describes energy of the electron and most probable distance of electron from the nucleus and represented by n, example KLMN. Azimuthal quantum number, it is associated with the angular momentum of an atomic electron and represented by L 0 to n minus 1. Example SPD of 0, 1, 2, 3. If L is the angular quantum number, subset of the maximum electrons can be hold is 2 into 2L plus 1, that is 4L plus 2. Subsets for L plus 2, 1, so is 0, P equal to L value 1, so 4L plus 1, 6, D L equal to 2, 4L plus 1, so 10, 4L plus 2, 10, F equal to 3, 4L plus 2, 12, 14. Magnetic quantum numbers, it is the permitted orientation of atomic orbitals in space and represented by m equal to 0 to plus L to minus L. For the d orbitals, L equal to permitted value for any subcells defined by the L value 2L plus 1 values 2L plus 1, 5. M equal to minus L to plus L, the magnetic quantum numbers for the L minus 2, minus 1, 0, plus 1, plus 2. So for F orbitals L equal to 3, the permitted voltage values of cells defined by the value 2L plus 1 to 7 orientations, and M equal to minus L to plus L, the magnetic quantum numbers minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. The examples of the p orbitals permitted values for the soft shell are defined with 2L plus 1 and 2L plus 1, 3. Minus L to plus L, minus 1 to plus 1, so Px, Py, Pz. A soft shell, the permitted value of soft cells 2L plus 1, so 2 into 0, only one permitted orientation. minus L2 plus n 0 minus 0 to plus 0 to, so yes, only magnetic quantum numbers n equal 0, 1s, 2s, 3s, etc. Spin quantum numbers, it represent the motion of electrons and that orbits in the information about direction spinning or rotating clockwise and anti-clockwise and represented as half and minus half. Significance of principal quantum numbers, it gives the average distance of electrons from nucleus represented by R equal to n equal 0.529, 10 to the power minus 10 meter, and principal quantum number to R proportionally n. It gives the average energy of the electron in a cell equal to minus 1312 over n square kilojoule per mole, that is E proportional n. It gives the maximum number of electrons that can accommodate in the cell, calculated by 2n squared. Significance of azimuthal quantum number, it gives the number of subcells present in the given cell. We know that L equal to 0 to n minus 1, n equal to 1, L equal to 0 to n 1 minus 1, so 0, n equal to 2, 0 to 2 minus 1, 0, 1. It gives the maximum number of electrons that can accommodate in the subcell for L plus 2. As only 2 electrons, 6 electrons, 10 electrons, and 14 electrons. It defines the shape of subcell in the electronic cloud. It gives that number of orbitals present in the subcell. Significance of magnetic quantum numbers. Magnetic quantum numbers determine the spatial orientation of the electrons class in the orbitals around the nucleus in 3D space. For S subcell, L equal to 0, M equal to 0. S subcell is the spherically symmetrical shape and represents probability of finding an electron in equal to along the 3 axis around the nucleus. For P subcell, L equal to 1, M equal to plus 1, 0, minus 1. It is dumbbell shape and oriented along the XYZ axis, lying perpendicular to one another and designed by PX, PY, PZ. For D subcells, L equal to 2, M equal to plus 2, plus 1, 0, minus 1, minus 2. For F subcell, L equal to 3, minus 3, plus 2, plus 1, 0, minus 1, minus 2. Note, it is the region or point at which the wave function cycle 0 and probability of finding electron is almost 0 and its sign change. And Bohr notes, total radial nodes equal to n minus L minus 1 n principal quantum number, L azimuthal quantum number. The number of radial nodes is present in the orbitals for SPDF orbitals is given by n minus L, n minus 2, n minus 3, n minus 4 respectively. For 1 is total number nodes, n minus L minus 1, value of L for S subcell 0, so 1 minus 1, 0. For 2S, 2 minus 0, minus 1, 1. For 3S, 3 minus 0, 1, 2. 4S, for T orbital L equal to 1, so 2 minus 1 minus 2, so 0, 3P, 1, 4P, 2. Nodal plane, the plane which passes through the nose and perpendicular to orbital axis is called nodal plane, that is electron density remains 0. The number of nodal plane for different orbitals equal to L. Pictorial representation of orbitals, charge cloud diagram. The most common way represents the atomic orbitals based on the probability associated with the electron wave. This gives rise to the electron dot representation of atomic orbital. The greater the density of the dot at a region, greater is the probability of electron to found there. Boundary surface diagram. The diagram represents the most of the electron cloud remains within this bounded region is called boundary surface diagram. The boundary surface diagram, the boundary orbitals correspond to the outermost maxima in radial distribution curves. positive, negative signs in Loeb, explain the overlap aspects. Okay, it's all about the atomic structure based on the BSc first year. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for your patience. That's it now. Bye bye. See you again.